Okay, here's a video for summarizing probability as we've done it in our lessons, and I'm doing this as a preemptive little bit of work for doing the probability practice exam. So if you're studying for that exam or you're studying for any future exam, this is a good place to start. Now I want to go over a couple things about probability. If I use this notation, the P of something, right? So let's say that I have a die. A die is, of course, a six-sided cube. And it has different numbers. So like 1 here, 2 here, 4 on this face, right? So if I'm rolling one of these, it's got the numbers 1 through 6 on it. So to just say something like this, the probability of getting a 5, that's P of 5, that is equal to 1 out of 6. Now the reason for that is that there is 1 5 out of 6 total. This is just a general idea of probability in that we're talking about a subset that we want, like the desired outcome, over what we call the sample space. The sample space is all possible outcomes. Now, if you saw a notation that looks like this, the probability of 5 or 3. That U is a union, and it means or. So what we're saying is, what is the probability of getting a 5 or the probability of getting a 3? And what the or tells us to do is it tells us to add. So the probability of getting a 5 is 1/6. The probability of getting a 3 is 1/6. When we add those, we get 2/6, which can actually be simplified to 1/3. If you saw something like this, the probability of 5 and 2, right? What this is asking is not the probability of getting a 5 and then getting a 2. What this is asking is this is saying, what is the probability of a single roll landing on 5 and 2. Well, that's impossible. There's no way for one die, right, this guy right here, to land with both a 5 and a 2 both facing up. So that probability is going to be 0. This right here is what we call an intersection. This is where both things need to occur. It is not necessarily multiplication. What it is it is always the middle of the Venn diagram. It is the intersection in the middle. So if I had something like the probability of getting a 5 and the probability of getting a 2, the probability of getting both of them, aka the middle of the Venn diagram, that probability in here is going to be 0. Now, when do you multiply? If you see something like this, the probability of getting a 5, a 5. What that means is we are rolling the die multiple times. Multiple experiments. Multiple outcomes. Or the way that we generalize that is multiple trials. Mean, take a guess, what operation? They mean multiply. So if I wanted to find the probability of getting a 5 and then a 5, that means the probability of getting a 5 and then the probability of getting another 5. So this is going to be 1/6, and then, it's multiplication, The probability of another 5 is 1/6. And when you multiply fractions, you multiply top times top, 1, and bottom times bottom, 36. Okay, so we really only multiply when we have multiple trials. Now there are a few different rules that we need to know. We need to know that the probability of A or B is equal to the probability of A plus the probability of B when they're mutually exclusive. Mutually exclusive means there is no overlap, meaning both cannot happen at the same time. If they're not mutually exclusive, then the probability of A or B is equal to the probability of A plus the probability of B minus the intersection probability of A intersect B. And the reason why that is because if I had a Venn diagram, this right here will be A, and this right here will be B. I'm going to shade in part A with black. I should probably actually use a highlighter because I can. So this is all of the people or all of the probability of event A happening. And I'll use yellow for this one. This is the probability or the number of people in B. Now here's the problem. When I add up A and B, I'm double counting those guys on the inside, right? I use them once for A, and then I use them once again for B. So I've added them twice. So when I subtract them off, essentially I'm just getting rid of one of those doubles. I realized I could have just done that. I'm just getting rid of one of those doubles. Now, independent. If things are independent, then the probability of A and B is equal to the probability of A times the probability of B. Now, that's if they're independent. If they're not independent, then it is the probability of A and B is equal to the probability of A times the probability of B given A. So it's almost the same exact rule. So that's if you're dependent or if you're unsure. Now remember that independent means one trial does not affect the outcome of the other. A good example of independence is like coin flips. It doesn't matter how many times I flip the coin, the probability of every coin flip after that is still going to be 1/2. Dice rolling, that's another example. We also have taking things with replacement. So that means putting things back. Non-examples, things that are dependent, are like choosing without replacing. So if I was like taking marbles out of a bag and not putting them back, so I started with multiple marbles, and then I take them out, right? So I have a few marbles. Let's say I have 4 marbles in a bag. The probability of taking this one out is 1/4. But if I take it out and it is now gone, the probability of taking out the next one is 1/3. So taking it out changes the probability. So that's without replacement. Now, how do I check for independence? That'll be it, and then we'll move on to the actual questions. Checking for independence can be done 2 ways. The probability of A and B being equal to the probability of A times the probability of B is one way to check for independence. The other way is if the probability of B is equal to the probability of B given A. If either of those are true, then they're independent. Okay, now that's all of the general rules. Now let's go through a few questions and see if we can flex these rules. I'm going to do this quickly. So we've done this in class already. If you have any questions, you can catch me in the morning, or you can slow it down and watch it again to see where my rationale comes from. Now, if you take the letters from the word over numerousnesses and put them all into a bag, you take out one letter at random, find the following probabilities. I'm not going to simplify any of these because I would just use my calculator to give a decimal answer. So now, I take out one letter at random. Probability of getting an O. Well, there are 2 O's, so there are 2 O's out of 18 letters total. The probability of an S, there are 4 S's, so 4 out of 18. Now you take out multiple letters, so it's multiplication. Note their value and replace them, so it's always going to be out of 18. These are independent trials. All right, so the probability of getting an N and then an S. So the probability of getting an N, what did I just erase? Okay. The probability of getting an N out of this word is 2. So it's 2 out of 18 times, because it's multiple trials, and there are 4 S's out of 18 still. And I don't care to do that. I would throw parentheses around those and do that in the calculator. Just in the interest of time, I'm not going to. Now, E, N, R. So the probability of getting an E is 1, 2, 3, 4 E's. So 4 out of 18 times N's is 2 out of 18. And then R is 1, 2. So it's 2 out of 18 as well. And I would do the same thing. Parentheses around all these, multiply them in my calculator, and give the decimal answer. Now onto a Venn diagram. There are 138 student athletes at Hawthorne High School. 48 students play tennis and 71 play basketball, while 21 people play both tennis and basketball. So here's the Venn diagram. They didn't tell me to draw one, but whenever I'm talking about 2 different groups, I'm going to want to do that. I'm going to want to just include a Venn diagram because it helps me make sense of the numbers. All right. So we have 2 groups. We have tennis and we have basketball. Now, we always start in the middle. So the 21 people that play both, they're going to go in the middle. Now, they say that there are 48 that play tennis, but I already have 21 of them down. So 48 minus 21 is 27. Basketball, they say that there are 71. So I already have 21 basketball players down, though. So 71 minus 21 is 50. Now, when I add these up, 27 plus 21 plus 50, right, and I add these up, I'm going to get 48, 98. So this total is 98 people in here. but I'm supposed to have 138. So if I go to this and I say, all right, 138 minus 98 means there are 40 left over that don't play either sport. You could back up a second, rewatch that again to see where all the numbers come from if you'd like, or you can try another example. This was on a lesson called mutual exclusivity, or mutually exclusive. Now, how many students play tennis only? 27. How many students play a sport but not basketball or tennis? That must be these guys. What is the probability of tennis or basketball? So if I'm doing tennis or basketball, that means that these guys play tennis or basketball, so do they, and so do they. It's always going to be all three. So when I add those up, I'm going to get 98 out of the whole total, which is 138. Definition of independence and mutual exclusivity I just covered in the first notes, so I'm not going to rewrite those. You have a provided Venn diagram here. So it's honor society members and math club members, and then these guys on the outside who aren't in either. When I add all these up, 32 plus 17 plus 19 plus 186, I'm going to get 254 people total. It's important to remember that the 186 on the outside is not the grand total. That's just the people who aren't in either club. The probability of being in honor society, that's 49 people in honor society out of the grand total, 254. Probability of math and honor. Well, who's in math and honor? Well, just these guys in here. So 17 out of 254, because they have to be in both math and honor. The probability of not being in honor society. So the people who are not in honor society. Get rid of them. So it's 19 and 186. So when I add those up, I'm going to get 205 out of the grand total, which is 254. Probability of honor and not math. So honor society and not math club, but in honor society. It's these guys. They're in honor society and not math club. So 32 out of 254. Honor or not math. Honor or not math. So if you're in honor or not math, you get included. So they're in honor, and they're in not math. So you only need to be able to check off one, right? So let's see, honor society, yep, they're in honor society and they're not in math. So they're included, they're good. Now these guys in the middle, the 17, they're in honor society, but they're not in math club. But they still got one check, so they're good. They're allowed. They're coming. They're included. This 19 over here. Are they in honor society? No. Are they in math club? Yes. So they're not in math club. At double negative. So these guys are not included. And the last guy's on the outside. Honor society or not math club. So these guys here, are they in honor society? No. Are they not in math club? Yes. So they're actually included as well. So if I add all of these up, 186 plus 17 plus 32, I'm going to get 235 out of 254. Now, honor or math, let me clear this. Honor or math is this and this and this. So I believe that is 49 plus 20 is 69, 68. So this is going to be 68 out of 254. Now this is the fun one. Honor, this right here stands for a given, honor given math. So given that we're in math club, that's what they're saying. So if I'm given that we're in math club, here's what I don't need. I don't need any of the other info. I'm given that I'm in math club, so none of the rest of this matters. So let's cross out everything else. On my paper, I would just do this by covering it with my hands, but you can't see my hands in this video. So that's it, just the math club guys. And actually, maybe I want to leave the titles over here just so it's a little easier to read. Okay, so I'll leave that title as well. Not these guys, because we're only talking about math club. Everybody else is crossed out. Okay, so now we're in a math club meeting. We're in a room, and it's only us and the math club people. So what is the probability that they are in honor society? Well, that pen is still a giant marker. Okay, what's the probability that they're in honor society given they're in math club? So how many are in honor society? 17. Out of how many total? 36. And that's the way you do it given within a Venn diagram. So let's move on. And let's talk about the two-way table. The two-way table, the way it works is all the rows and columns all add up to give us the totals. They all add up in this direction, and our totals can be found on the bottom and on the right. So all my probabilities should pretty much be out of 226 unless there is a given. So the probability being a male, there are 112 males out of 226 total. Like I said, I'm not simplifying any of these because I'm just going to use my calculator to make a decimal when I report these on a quiz. Probability being female, there are 114 females out of 226 total. The probability of somebody preferring the Olympic hockey is 130 out of 226. The probability of somebody not liking Olympic hockey, so I guess they prefer NHL then, is 96 out of 226. The probability of NHL and male. So who's male and in the NHL, or prefers NHL, sorry. Male is here, male is this row, and prefers NHL is here. So it's this number right here, 63 out of 226. And the last one for this section is the probability of male or NHL. So remember the check mark scheme. These are the totals. I don't really care about them. Those are just the totals. We want to know about the groups. Are the groups included? So let's see. If you're male or you're in the NHL, you get to, or you prefer the NHL, you get included. So these guys right here, they are included because they're male and they prefer the NHL. So they're good. They're coming. They're included. Now, these people, they're male, they prefer Olympic hockey. Well, they're male, but they don't prefer NHL, but they got one check mark, so they're still coming. Okay, they're still included. What about these? They're female, and they prefer NHL hockey. So they're not male, but they prefer NHL. So they got a check mark, they get to be included. Remember that an OR only requires you to meet one criteria. So these right here are females who prefer Olympic hockey. So they're not male. They do not prefer the NHL. They are not included. So what we do is we'll add these up. 63 plus 33 is 96. Plus 49 is 95 plus 50 is 145. So we have 145 out of 226. Now, are female and Olympic independent? Okay, so independence. We have two checks for that. I'm going to call this A, and I'm going to call Olympic B. And I'm going to use this version of the equation. The probability of A and B is equal to the probability of A times the probability of B. And let's check this. The probability of being female and preferring Olympic hockey. That's what this means. Female and Olympic. So female and Olympic. That's 81. So this is going to be 81 out of 226. And let's see if that's equal to the probability of A, which is female, the probability of being female. So it's 114 out of 226. And times the probability of B, which is the probability of preferring Olympic hockey. So that is 130 out of 226. Now, suffice to say, I could just do this right side of my calculator and see if these are indeed equal. So let me just zoom in a little bit so I can see these in the little window, and I'll show you that they are not actually equal. So 81 out of 226, that's 0.358. And the other one is 114 over 226 times, and let's see what the other number is, 130 over 226 times 130 over 226, and enter. And that's a different decimal that's not equal. So 0.36 is not equal to 0.29. 0.36 is not equal to 0.29. These are dependent because they're not equal. Moving on to our last page. Last page? Yes, last page. Okay. The probability that Marie smokes and gets lung cancer is 0.2. She smokes and gets lung cancer is an and probability. The probability that she smokes is 0.52. That seems like it'll be useful. And what do they want? What is the probability that she gets lung cancer given that she smokes? Now, smokes and gets lung cancer, that's a formula that looks like this, right? Probability of A and B. And then I have a given in here. So I think the equation that I should use is this. The probability of A times the probability of B given A. So there's only one formula that really matches up with this kind of question. So let's see. She gets lung cancer given that she smokes. So she gets lung cancer given that she smokes. So we have B given A. This is going to be B given A. So B is lung cancer and A is smokes. So let's see. The probability of A and B, so smoking is A, and B gets lung cancer is 0.2. Okay, this is 0.2. The probability of A, the probability of A is smoking, right? Oh, cool, this is A. The probability she smokes is 0.52. So is equal to 0.52. And they actually said, what is this last probability? So we're just trying to solve for it. So we do that by getting rid of the 0.52 with division. And 0.2 divided by 0.52. 0.2 divided by 0.52 is 0.385. And that's the answer for that question. Now this two-way table is nice actually because it's already probabilities. Because it's all going to be out of 1. So let's see. The probability of studying. Studying is here, 0.6 out of 1, which is 0.6. Probability of passing. Passing is all in this row, so passing is 0.7 out of 1, which is 0.7. The probability of passing and studying, that's 0.42 out of 1, so 0.42. The probability of studying and failing, that's 0.18 out of 1, so 0.18. Probability of failing, cake, easy. Failing is 0.3. out of 1, which is just 0.3. Passing or failing. So passing or failing. So these are mutually exclusive. There's no crossover. So we can actually just add these together. Probability of passing is 0.7. This is or, so it's plus. And failing is 0.3. So this equals 1 or 100%. Now, passing and not studying, that symbol means not. Passing and not studying, so passing, not studying is 0.28 out of 1, which is 0.28. Passing given studying. Now here's where the fun stuff comes, right? Okay, I can't cover things up with my hands because you can't see my hands. So pass given study. So this condition here, the study, that tells me the only data I should be looking at. So remember, I'm only interested in studying right now. So the rest of this is not important to me for question 32. Now that I'm only looking at the studying, the given condition, what is the probability that I pass? Well, passing is 0.42 out of what? 0.6. 0.42 out of 0.6. And a calculator will tell you that this is 0.7. Okay, let's do another one. Fix up the table. Question 33, study given passing. So given that I pass, so I want to cover up everything except for passing. So everything except for passing is getting covered up by my hands, which right now looks like a purple ink blob. So now, the probability that I study given that I pass. So studying is 0.42 out of what total? 0.7. So 0.42 out of 0.7, and this equals 0.6. Fail given pass. Fail given pass. So if that's actually the same thing. So given pass, cover up everything but passing. Now how many of these are failing? So this is passing, this is passing, this is passing. Ah, man, it's a trick question. The answer is 0. Now the next question, probability of pass given fail, explain your answer. So if you're given that you failed, there is 0 probability that you passed. Okay. Last two, are studying and failing independent? Okay, so I'm going to use my favorite rule for this one. Studying will be A, and failing will be B. The formula is the probability of A and B is equal to the probability of A times the probability of B. So studying and failing. What's the probability of studying and failing? I'm pretty sure we actually have that already, but let's see. Studying and failing is going to be 0.18. Okay, so let's see. So this is going to be 0.18. Should be equal to the probability of A, which is the probability of studying. Let's go back to the table. The probability of studying is 0.6 out of 1. That's the total for studying. 0.6 out of 1, which is just going to be 0.6 times, that's a messy decimal point. Okay. Times the probability of B, which is the probability of failing. So let's see the probability of failing. The probability of failing is 0.3 out of 1, which is just 0.3. And if I do this right side in the calculator, this guy right here, I get 0.18. So 0.18 is equal to 0.18, and that means that they are independent. Now, what does this mean about test preparation for the class whose data is presented in the table? Since studying and failing are independent, for this class it makes no sense to study, because it won't affect your probability of failing anyway. By the way, this is not true of Algebra 2. Okay, now that's the whole test. If you had any questions, feel free to roll back to the question and rewatch that part of the video, or go back to any of the earlier lessons, which is like 85 through 91. Okay, enjoy.